title adjustment. Let's start with the first tutorial. So first of all, I just want to introduce a little bit myself to get an idea why I'm presenting kind of this content. So the idea is over the past 4 years, I was in the Synergia consortium, working more on developing the connector mapper and coordinating kind of organization of the data and processing of the data within the project. So in summary, it's how I end up in this standardization world where like two kind of main standard came in the past years. That was first the brain imaging data structure, BIDS, and secondly, more like the BIDS ecosystem that was creating so many different tools, and a part of them, there are the so-called BIDS apps. So the idea of this first tutorial is to introduce you to the brain imaging data structure, its ecosystem, and more importantly, to introduce you to the data set that we're gonna use in most of the tutorial during this summer school. And so the tutorial, you can find kind of a main page directly in the tutorial material website. And then you can just follow this link and you're gonna get to the slide of my presentation. So the brain imaging data structure. So the outline of this tutorial is to first introduce you the brain imaging data structure itself and introduce you what it is, why it's so useful. And then to get more like to practical session where you're gonna get familiar with this standard and the data set that we're gonna use during the summer school. And then a very little part just to note actually when it's, we are talking about your own data, then how you can get to this BIDS organization. So what kind of tools are available? So what is BIDS? So BIDS staying for brain imaging data structure. It's just I would say a community standard that was developed 4 years ago to describe and organize the neuroimaging data and also the metadata. So it's kind of very all the information essential that the data set or the data itself can explain itself by itself, and not, by like your colleague that just explain what happened in the data. And so this was developed by a community of scientists, and some of them were part of the International Neuroinformatics Coordinating Facilities, so the INCF, and a lot of different scientists from the neuroimaging field. So the idea in some of BIDS is you see on the left-hand side is kind of the type of data you're gonna get from an MRI scanner. So like for us, it really doesn't tell us anything about the content of these data sets. And BIDS is just consisting on a set of rules for the file organization that in somehow then it's kind of very intuitive what kind of content, what type of files is included in the data sets. So why BIDS? So there are like many different advantages in adopting BIDS. So first is about data sharing and reproducibility. You have been like in many, I guess you already got into the situation of a colleague, is like sharing his data set with you, and you are, and it just takes a lot of time for you either to get an idea what really like the data is about, and also sometimes just some very important information related to acquisition, for instance, the echo time or some other parameters. And so BIDS in this sense, it just facilitating this sharing of data, because in somehow you already expect to see the data, a certain organization of the data, and directly based on the documentation of BIDS where critical information, very important information can be found. And so in somehow, by extension, it allows us to better also assess and reproduce other experimental findings if you have improving data sharing. Second, the ecosystem of tools. Based on the BIDS, so it's a specification, then there are a lot of tools that are just built on the BIDS specification. And all those tools can be from the validation of your dataset, so to detect any type of error in the organization or missing information. They can be like an open database, like OpenNeuro, that has been kind of developed for sharing datasets. And especially what is the most important is the first database that was accepting BIDS as a standard for the organization. PyBids, that, for instance, is a Python library that can really help you in interacting directly with the BIDS formatted dataset. So what I mean by interaction, mean how you can get a listing of, for instance, all the different T1s for a specific subject or for all subjects, or to know what kind of tasks are available in this dataset. So all this kind of information can be retrieved very easily with a little library. And there is exactly the same library for MATLAB as well. And the so-called, I was already mentioning before, the so-called BIDS app, that are a collection of portable neuroimaging analysis pipeline. So in somehow, when you are like in a BIDS format, then you can use all this collection of softwares to very easily, I would say, generate new outputs in your research workflow. A third point is about core sharing, because in somehow when you are writing your code that is able to understand a BIDS dataset, actually at the same time you are almost to create a BIDS app that has the potential to be applicable to all different dataset that has been already organized following this standard. And so I would say your code can have much more impact because there is kind of, how you can really share your code and people can use it. It's still kind of very hard for people to to promote code, and especially if they're using their own format organization. But as there is a proper standard, then anyone can use your tool directly to their own data set. So it's really going to improve also sharing of your code. So with all of that, actually our BIDS is different from the existing solution. So actually it's not so different, but the existing solution actually are more online databases. So in somehow it makes it more harder to manipulate with the data, and it also make I would say a solution completely dependent on the database. Then, like I would say in opposition, in contrast to that, BIDS is just a collection of files structured in folders and following this specification. And it is intentionally based on simple file formats and folder structure, ready to reflect best current lab practices and to make it accessible to a wide range of scientists. BIDS actually, like the way it is decided, is a consensus. So all things that are included in the specification reflect to the best, and I would say to the consensus of all practices. And then the last point that is actually not the least, but also very important, is actually all, I would say, the principle that he focuses on. And so he's focusing on interoperability, on like a simple organization, so on simplicity, on the data sharing itself. So it's why I was talking about also storing and organizing some metadata. So it's to make it also much more findable and discoverable, and it's community oriented, so anyone can be part of it, and it's very extensible. So for instance, it has been originally developed for MRI, but it has been already extended to MEG, EEG, intracranial EEG, and there is, I would say, around 20 different BIDS extension proposal ongoing now. So I will say that was my part on the introduction on BIDS. Now we're gonna get more on something that is a bit more practical, and this step gonna be to get more familiar with BIDS and the summer school datasets. So the summer school dataset consists of a sample of a dataset that actually we collected and published in this Synergia project. That is the webcam dataset, that is a multimodal neuroimaging dataset that is providing some anatomical diffusion data and also high-density EEG. And so, as you see here, I show you a very kind of an overview of the structure of this dataset and the BIDS dataset. So here, that's very the root. So you're gonna be able to find it in the virtual machine. So here I'm using the virtual machine already. You're gonna find it in this folder. So in the data folder in your home directory under this name. And then the dataset itself consists of the main, I would say, files imposed by BIDS to describe the dataset itself. So there is first a data description JSON file that, like the purpose of this file is to describe very briefly the dataset and give, for instance, some link to some digital object identifier, for instance, to be cited, and the different, the list of authors, the very brief information about the dataset. All the participant files, one is in TSV format, so it's a table, I would say just a table, that's gonna store all demographical information of the participant. And the SICA JSON file that you see that is having exactly the same name. Actually, the JSON file, usually, if you have two files that are having the same name, but one is JSON file, usually it's giving some more information, some description about the content of the other file. So for instance, the participant.json, it just, the goal of this file is to describe the columns of your participant.tsv table file. And then you've got two different files that are actually more helping, I will say, a user to get an idea about, the history of a dataset, what happened in the dataset. That will be the changes file. And there is a README, like when you are sharing your code on Git, for instance, you're gonna get a README of your code. So the README is kind of the landing page of your dataset. So it's kind of way you might describe your dataset in more details, and introduce already what the user can expect to find inside. For instance, if I know one subject, I would say the EEG recording was very too bad because of too much motion, and we had to extrude it from the dataset, for instance. That would be the place to state, to make clear that actually we have missing data for this particular subject. And then you really find for each subject, you're gonna find a specific folder, and then you're gonna get a specific folder for each type of modality. So here we are very differentiating between anatomical MRI and diffusion MRI and EEG, for instance. And then, as you see here, so images in BIDS should be in a Nifty format, so you can get the Nifty, or here it's a Nifty that has been compressed, so it's why the .gz. And then you're gonna find always, I would say, accompanying this Nifty file, you're gonna always find this JSON file that actually is saving you acquisition parameter that are in the DICOM, but then are totally lost during the Nifty conversion. And And so it's kind of the purpose of this JSON file to really, keep all the information that are very important to get, I would say, the meaning of the data that you are using. So for the diffusion, gonna be the same, but diffusion is also like, I will say, you're gonna get 2 extra files that are very due to the nature of the image itself. And diffusion, as Marco was presenting, is you acquiring, like the diffusion in different direction. And so you need like extra information about saying like for what was the gradient sensitivity direction for this particular volume in 3D. And that's the purpose of those BVEC and BVAL, because the BVAL gonna give you like kind of like the sensitivity and getting the diffusion signal. And then you're gonna get all files that are related to the EEG. So one is about I would say the location of the electrodes, such that we can create the form model for inverse solution. So here, for the purpose of this summer school, the electrodes have been already registered to the T1. So here, what you're gonna find is the electrode position directly in the T1 native space. And then you're gonna get different files for the EEG itself. So here you're gonna get a raw EEG data. So we are using the biosemi format that is supported by BIDS. They are like a different format that are imposed by BIDS. The JSON file is exactly the same than for the T1 or the diffusion. So it's gonna describe some acquisition parameter, for instance, some information about the amplifier also to record the EEG. The channels is more about voltage and not position. And then if you have a task experiment, then the events file is, the purpose of this file is really to describe each event that happens. And as I was mentioning, the JSON file here is just used to describe the columns of the event. So in this way, to have like a description of the columns actually help you to be very flexible. And so it's kind of one of the reasons of success of BIDS is not so strict in imposing some, I would say some flexibility, some very, I would say it's not imposing you like exactly how you should describe an event, because that might change between a lab or an experiment, but it's gonna give you exactly the same framework. And so in the end, everything is still meaningful and everyone can be happy because they can still tune, I would say, the standard to their own purposes, to their own sake. And finally, the derivatives folder. It's a folder that is being used to store all the process data. So here we're gonna store the data generated for my second tutorial, for the third tutorial. I'm not sure about the next for tomorrow, but the idea of the derivative folder is kind of, okay, I have all my source and now it's like all my process data going into this folder. And that's it for, oops, sorry. So for this, so now I'm really gonna start more like, I will say, the tutorial itself, the practical parts. So here I'm just, as I was saying, gonna use this sample of the webcam dataset, and this comes already preloaded in the virtual machine. And just if you really want to follow along, just make sure that the virtual machine is ready. That's kind of. So, so for this tutorial, I kind of created two different exercises. The first one was kind of a little, I would say, exercise such that you can get familiar with kind of the file naming scheme and the file and the folder organization as well. And so what I did is I took actually a sample of the summer school datasets, but then I mess up that such that it doesn't comply anymore with the BIDS standard. And the goal of this exercise is just to make it compliant to the BIDS standard again. So what I can show. So the dataset itself can be found in this home data and then the GA003505 sample. So if I go in the data folder, then you're gonna find the sample datasets. And so what you see here, actually, it's you don't see anymore any BIDS related organization. And so the idea here is to kind of, I would say, make it compliant. And to make it compliant, it consists on a few steps. One is about the file naming itself. The second is about the file or folder organization structure. So what I was checking now, it was more like, like this organization and naming. Here, what I'm putting is there is a little command line. Actually, I'm not sure if it's already installed or not in the virtual machine, but it's this command tree, and this tree actually very easily in your terminal gonna give you kind of the content of the. So if I'm doing this, I can also increase on this. So if I do this and then so as you can see, it's exactly kind of the same layout that we were seeing visually, but it's more in the terminal. But there is always a way to go through the terminal to see content of files and so on. The idea here is we see exactly the same, no good structure, no good file naming. So the first thing I would say will be to create the structure, and then you can rename and move appropriately the files. So first, how to create the BIDS folder structure. So how I was showing before, there is this subject and then modality type structure of folders, and then all the data itself is going into one of those folders. So what you have to do here actually is just to create those two folders. So I'm just gonna do exactly as we did here. So what I'm gonna do is just copy and paste my instruction. And in case there is something that doesn't work, then I can correct for it as well. So here, what I'm doing is just kind of a shortcut to not write all the time the path to the directory, but I'm just saving in this variable that is called BIDS_dir. And then here, what I'm doing is just creating those two folders that are called sub01 and anat, and then the DWI inside. This -p is just an option to say, to create kind of intermediate folders. So now, like all the different, like here I'm taking a kind of a command line approach, but all this approach of creating folders and renaming file can be very easily done as well, directly in the graphical interface, more like graphically than by command line. But it's just by a cycle to follow my slides, I'm just doing it command line based. So here we go. So now if I look at my data set, now I have this structure of folders. And now the next thing is to move, for instance, the diffusion data into the diffusion folder and the T1 itself to the anatomical folder. And at the same time, as you can see, this is very far away from the type of name that you saw before for BIDS. So the idea is when they are moved, they also should be renamed accordingly to the BIDS standard. So the first thing that was not in the file naming standard was at the root of the dataset is this subject demo that actually is storing the demographical information of the participant. And as I was introducing and talking about it before, actually this file should be named participant.tsv, and then the JSON is there just to describe the columns. So here, what you see actually is just I'm moving this file. So in somehow, I'm just renaming this file to be participant.tsv, and there is a typo here, but then I should rename the JSON to participant.json as well. So that's what I'm gonna do. There we go. Now we can check again. So here, now you see those two files, now they have been renamed and they should be BIDS compliant. The next one are the diffusion and the T1 image file. And so here, the idea is I'm gonna rename the T1. So the idea of the file naming scheme is you get different entities. So what is called entity is always a kind of a pair of one side is the entity. So for instance, sub, but you might find a lot of different entity keywords in different file names. For instance, you might find the entity task, and then you're gonna use on the right side of a dash, then a label for this specific entity. So for instance, you can have an entity that is a task, and then the label gonna be the type of task. That's something that you're gonna see a bit more in, I would say, in details when you are looking at the original sample summer school data set with the EEG data, because they are using much more entity than here, that we're just repeating the subject entity. But what you see here, it's you need to repeat all the time the subjects in the file name itself. It's very also in somehow to reduce error of not getting the proper input data. For instance, you are messing up like two different subjects, and just to make sure that such error is not happening. And for the diffusion is exactly in the same idea, but then you are using a different suffix. So the suffix is the end of the file. So as you can see, the diffusion weighted images is described as this kind of acronym directly in BIDS. And DWI is kind of a specification of BIDS for describing a diffusion data type. And then we can rename the JSON, the b-value file, and the bvec file accordingly to the same name. So they are very like all together. It's kind of a package for the diffusion data. So what I'm gonna do now is just moving and renaming files. And then normally when file is going to be renamed, we should be close to have a BIDS compliant data sets. And then I can show you actually, I was talking about this BIDS validator that can tell you if this data set is BIDS compliant or not. And that's something that I'm going to show you afterwards. So now everything should be up to date. And so now you can really see that the structure and the name of the file, they are like very similar to what I already introduced to you right before when I was introducing the summer school datasets. And so now if we go to so there is a BIDS validator that is online. And the idea is, so I will advise you, if it's a little data set, you can use the online validator. If it's start to be a lot of different subjects, I will advise you to install the BIDS validator on your platform. Like here, it's a very little sample, so done. So now if I'm taking, so my sample data sets as my BIDS. So now what you see is the BIDS validator is happy. It can tell you that he's having one subject, one session, and then there is only MRI modality there. Actually, that's something I forgot to do at the beginning, but if you will do exactly the same with the first data set, you're gonna get a lot of different errors that are gonna be listed, and definitely the BIDS validator won't be happy. So the BIDS validator, the idea here is it's gonna help you in investigating different issues that you might have in your data set, and that might help you and save you a lot of time. And detect, for instance, like a little typo in a file name or something like this, or missing information as well. Or also, you're gonna raise you some warning if some parameter of acquisition change between subject, or if there is not the same, exactly the same type of scans between subjects. So if it's not consistent among the subject, among the session, and so on. So it's very NVSID, it's really gonna help you a lot. And so that's what I just did now, was to validate my data set with the BIDS validator. So now the second little exercise around BIDS was to kind of show you how to interact with the data set in Python. And here the idea was to introduce you in using the PyBIDS library for that. So the idea here is we're gonna run Python, so it can be IPython. You can also run directly a Jupyter notebook and then enter in a notebook all the different commands. It's very up to you. Like now, what I'm gonna do is very simply IPython, and in the terminal, writing the code. So I'm gonna launch IPython. And so here, the idea is in the virtual machine, I already made you a Python environments where all the different packages are installed. And it's why you are seeing this prefix that is this py37 cmpguy. The idea is the Python environment of connector mapper that then I also, I would say, pimp it for the summer school, that we can run also different other tutorials. And so the first thing is to use the PyBIDS library. So in Python, what you need to do when you want to use a module is to import it. And what we want to import it from the PyBIDS library is this BIDS layout class that actually is the aim is to describe and store a BIDS data set, and then you can really easily interact with it. Here we go. So this BIDS layouts, the main, I would say, argument that is taking for initialization is just the BIDS root directory. So the root directory of your BIDS dataset. So here, what I'm saying is I want to go to my home data, so the proper summer school dataset. Okay, don't worry. Just for the sake of clarity, but the idea is just Python is not happy with the environment variables, so I have to put the pass in. The idea of the BIDS layout is kind of then putting your data set in a database format that then you can carry files very easily. So it's why at some point it's taking a bit of time to be initialized, but then to carry a list of files is very, very fast. And then what you can do is, as long as you have represented your BIDS dataset as a BIDS layout, then you can easily print the layout object that you created. And here you get also kind of the very brief information about your dataset, how many subjects, how many sessions, and how many runs are inside. Now, how can you get, for instance, a list of T1 images for the subject 01? So this can be done with the get method of the BIDS layout object. And this, as you can see here, I'm just specifying different fields that are kind of important to extract, like the T1s themselves. So one is about carrying a specific subject. The other one is about the extension of the file. What type of file? If you want the JSON, for instance, or if you want the Nifty. The suffix gonna be the last part in the file name. So here it's gonna be the T1, but if it's diffusion, it's gonna be DWI. And then what we're interested here is a list of file names of paths. So that's kind of what we're like telling PyBids what it should carry for us. And so what I'm gonna do is so here what I'm gonna do is just to enter this command. And now if you are printing the result of this command, actually, it returned you, there is only one image here, but it was able to find it. And that's very kind of the power of BIDS is as long as your, I would say your data set is organized by BIDS, you can very easily generate file names and get file data existing and not based on assumption that the file is there with this file name and in the end actually is missing. So that can really reduce also some error of missing data or not finding the data. Now, the next step was to introduce you, so how to get the diffusion data, but like with a second format of calling the get method. And this is kind of, using like more feature of Python that is the dictionary. And so here, the carry of the file that we want is not structure as before, as a like input argument of the function, but it is structured as a dictionary with some field and the value corresponding to that field. So for instance, here I'm saying subject should be 01, extension should be nifty.gz, and so on. So exactly same information than here, but just a little like in a very slightly different layout. And so here, what is happening is actually a dictionary with those two little stars in front, actually gonna convert the dictionary directly in this kind of, you get the field that is equal to this value. So actually that's what is happening here. It's just converting this structured dictionary in exactly the same type of structure as here. So now what I'm gonna do. So yeah, in case you are doing some copy and paste like me, be very careful about indent in Python. So it's why I'm always correcting those indent, because otherwise you might just get some syntax error. Oh. And now, if I print the result of this query, here we go. You see, it managed to find like a file that they are still also using object-oriented programming. So they are still returning an object that is a BIDS image file. And the file name is exactly our diffusion data. So all good here. And the last part is not about obtaining files, but it's about obtaining other information, such as like listing the different tasks that are available for EEG. So here, the sample is giving you only one task, but the original webcon is having two different tasks. So one is a face and one is about motion. And so if you are like getting directly the webcon dataset, you're gonna get two different tasks. Here, what you're gonna get is only the face task that's gonna show up. So I'm gonna show you. And now, if I show you the task, you're gonna see there like he was able to find that there was a face. And this is due, so what is happening is when you go into the EEG, what you see is, you get entity label for subject, then entity for task, and then a value for this entity. And so in somehow, it's just looking for all the different value that can be for this task entity and return you this value. So that's really how it works. And so any file that I kind of, I would say, organize with the structure of entity label underscore entity dash label underscore blah, 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 actually can be very easily retrieved by this layout get method. So it's very, very, I would say, which one?
Non, ça, on vient un peu les fenêtres, tu peux décaler là.
Ah, that's him.
Ah, that's it. Ah, merci.
Yeah, sorry, guys. Okay, so that's what was about the task. And now the last part. So that was kind of, to show you how to get familiar with BIDS and how to interact. But then on your side, what you might be more interested is, okay, I have data now, how I can get to a BIDS organization. So here, I'm not gonna spend too much time because I will say it's a whole tutorial, but there are already a lot of different tutorials that are existing online. And then you might have different packages depending on the type of modality you want to convert. So for instance, for MRI, that I will say is the most developed, so the most rich ecosystem of tools. Then you might get the DCM to BIDS, EDIConv, the BIDScoin, the BIDS kits, the BIDS toolbox, and many others. For EEG, you're gonna get more, I would say, like most of all software, they were actually already kind of involved in the designing of BIDS EEG, so the Emini, Field Trip, EEG Lab, but also you're gonna get Brainstorm or Brain Vision that also have some conversion tools. And then if you get more physiological recordings, there are some ongoing draft and tools that have been developed that are those physio2BIDS, or also there are some projects of integrating in this BIDScoin. But to be honest, most BIDS converter, at some point, they require a bit of user input and work. So the idea is to kind of facilitate to as the best as they can, to help you in different steps. But then there are also steps like the way I know your sequence in MRI are saved, and you have to distinguish between diffusion and anatomical might be different between hospital, but also like just in a matter of a month, there was like an upgrade, like a change of a sequence name, and then things are changed. So there are always a bit of, I would say, of adaptation, and you're gonna always have to give a bit of user input to those converters. And so so I would say on the page of the tutorial in the material, so here, you can find a lot of different links about tutorials, like videos that show you how to use the different tools I was mentioning before. So on this, what I want to, I would say to sum up at the end of this tutorial is, I would say, emphasize is those two main key points around BIDS. So one is about BIDS, it's kind of community-driven standard, and it's just like a simple way of organizing files, what kind of file format we're using, in which of consistent format we should store some documentation information, so description of the dataset, description of the acquisition parameter, and all of this to, I would say, is the reuse of your dataset, I would say by others, but also by your future self. And also your future self gonna be happy with your, I would say, your current self in a year to be back in the same organization than to kind of be in this loop of how did I organize a year before? So BIDS is very not a new file format or a search engine or a data sharing tool, but it's just like a way to organize and describe the data itself. All the file formats, they are kind of commonly accepted by the community, and they are not created there. And then there exists a large ecosystem of tools around BIDS, and they can support you in all the tasks, from dataset creation to validation of the dataset to interaction and analysis. And all of this is usually made by more like community people, and they are also creating a lot of different great tutorials. So on this, I'm gonna stop.